Binomial distribution. Definition: a random variable x is said to follow binomial distribution with parameters n, p, if it assumes only non-negative values and its probability mass function is given by p of x equals ncx p power x q power nx, x equals 0 to 1. Notation: x follows binomial distribution b of n, p. Remark: binomial distribution is a legitimate, valid, probability distribution. Since summation over x equals 0 to n, p of x equals summation over x equals 0 to n ncx p power x q power nx equals q power n plus nc1 q power n 1 p plus nc2 q power n 2 p square plus extra plus p power n equals 1. 2. Let us suppose that n trials constitute an experiment. Then if this experiment is repeated n times, the frequency function of the binomial distribution is given by f x equals n into p of x equals n into ncx p power x q power nx, x equals 0 to 1. Moment generating function. Short form is MGF. mx of t equals e of e power tx equals summation over x equals 0 to n e power t x p of x equals summation over x equals 0 to n e power t x ncx p power x q power nx equals summation over x equals 0 to n ncx p power t whole power x q power nx equals q caret n plus nc underscore 1 p e power t q power n 1 plus nc 2 p e power t whole square q power n 2 plus extra plus nc n p e power t whole power n q power nn. Sat smiley q plus p e power t whole power n. Mean and variance. Moment generating function mx of t sat smiley q plus p e power t whole power n. Differentiating with respect to t, we get mx dash of t equals n dot q plus p e power t whole power n minus 1 into p e power t equation number 1. Put t equals 0, we get mx dash of 0 equals np. Therefore mean equals np. Again differentiating equation 1, with respect to t, we get mx double dash t equals np into n minus 1 q plus p e power t whole power n minus 2 dot p e power t dot e power t plus q plus p e power t whole power n minus 1 dot e power t. Put t equals 0. We get mx double dash 0 equals np into np plus q. Hence variance equals mu2 dash minus mu1 dash whole square equals npq. Since mu2 dash equals mx double dash of 0, mu1 dash equals mx dash of 0. Problem 1. The mean of a binomial distribution is 20 and standard deviation is 4. Find the parameters of the distribution. Solution. Given mean is 20 and standard deviation is 4. That is np equals 20 and square root of npq equals 4. npq by np equals 16 by 20. Implies that q equals 4 by 5. Therefore p equals 1 minus q equals 1 by 5. Now np equals 20 implies that n equals 100. Hence the parameters of the distribution in 100, 1 by 5. Problem 2. The mean and variance of binomial distribution are 4 and 4 by 3. Find p of x greater than or equal 1. Solution. Given mean is 4 and variance is 4 by 3. That is NP equals 4 and NPQ equals 4 by 3. NPQ by NP equals 4 by 3 into 4 implies that Q equals 1 by 3. Therefore P equals 1 minus Q equals 2 by 3. Now NP equals 4. Here substitute P value. Implies that n into 2 by 3 is equal to 4. We get n equals 6. We know that P of x equals NCX P power x Q power n minus x. P of x greater than or equal 1 is equal to 1 minus P of x less than 1 is equal to 1 minus P of x equals 0. Equals 1 minus 6c0 2 by 3 whole power 0 1 by 3 whole power 6 is equal to 1 minus 1 by 3 power. Equals 0.99. Problem 3. Problem 3. A binomial variable x satisfies the relation 9 into P of x equals 4 tongue-poking smiley of x equals 2 when n equals 6. Find the parameter P of the binomial distribution. Solution. Given 9 into P of x equals 4 tongue-poking smiley of x equals 2. Implies that 9 into 6 C4 P power 4 Q power 6 minus 4 equals 6c2p square q power 6 minus 2. 9 into 6c4p power 4q square equals 6c2p square q power 4. 9p square equals q square. Taking square root on both sides, we get 3p equals q implies that 3p equals 1 minus q implies p equals 1 by 4. Problem 4. Out of 800 families with 4 children each, how many families would be expected to have I. 2 boys and 2 girls, 2. At least 1 boy, 3. At most 2 girls and 4. Children of both sexes? Assume equal probabilities for boys and girls. Solution. Given n equals 800, n equals 4. X denote the number of birth of a boy. P probability of the birth of a boy. Therefore P equals 1 by 2 and Q equals 1 by 2. I. P of 2 boys and 2 girls, tongue sticking out of X equals 2 equals 4c21 B2 power 2 1 by 2 power 4 minus 2 is equal to 3 by 8. Therefore number of families having 2 boys and 2 girls equals n into P of x equals 2 equals 800 into 3 by 8 is equal to 300. 2. P of at least 1 boy tongue poking smiley of x greater than or equal to 1 is equal to 1 minus P of x equals 0 equals 1 minus 4c0 1 by 2 power 0 1 by 2 power 4 minus 0 is equal to 15 by 16. Therefore number of families having at least 1 boy equals n into P of x greater than or equal to 1 is equal to 800 into 15 by 16 is equal to 750. 3. P of at most 2 girls tongue poking smiley of exactly 0 girl, 1 girl, 2 girls. Tongue sticking out of x equals 4 or x equals 3 or x equals 2. Tongue poking smiley, x equals 4, plus P, x equals 3, plus P, x equals 2. Equals 4c4 1 by 2 power 4 1 by 2 power 0 plus 4c3 1 by 2 power 3 1 by 2 power 1 plus 4c2 1 by 2 power 2 1 by 2 power 2. Equals 1 by 2 power 4 into 4c4 plus 4c3 plus 4c2 equals 11 by 16. Therefore number of families having at most 2 girls equals 800 into 11 by 16 is equal to 550. 4. P of children of both sexes equals 1 minus P of children of same sex equals 1 minus of P of all are boys plus P of all are girls equals 1 minus of P of X equals 4 plus P of X equals 0 equals 1 minus of 4C4 1 by 2 power 4 1 by 2 power 0 plus 4C0 1 by 2 power 0 1 by 2 power 4 minus 0 equals 1 minus 1 by 8 is equal to 7 by 8. Therefore number of families having children of both sexes equals 800 into 7 by 8 is equal to 700. Problem 5. An irregular 6-faced dice is such that the probability that it gives 3 even numbers in 5 throws is twice the probability that it gives 2 even numbers in 5 throws. How many sets of exactly 5 trials can be expected to give no even number out of 2,500 sets? Solution. Let X be the number of even numbers and P be probability of getting an even number. We know that P of X equals NCX P power X, Q power N minus X. Given P of X equals 3 equals 2 into P of X equals 2. Implies that 5C3P power 3, Q power 5 minus 3 is equal to 2 into 5C2P square Q power 5 minus 2. Implies that P equals 2 Q implies P equals 2 into 1 minus P implies P equals 2 by 3. Therefore Q equals 1 minus P equals 1 by 3. P of getting no even number tongue poking smiley of X equals 0 equals 5C0 P power 0 Q power 5 is equal to 1 by 3 power 5 is equal to 1 by 243. Number of sets having no success in N sets equals N into P, X equals 0 equals 2500 1 by 243 is equal to 10.2881 approximately 10. Problem 6. 10 coins are thrown simultaneously. Find the probability of getting at least 7 heads. Solution. Let X denotes the number of heads and P be the probability of getting a head. Therefore P equals 1 by 2, Q equals 1 by 2 and N equals 10. P of X greater than or equal to 7 tongue poking smiley of X equals 7 plus P of X equals 8 plus P of X equals 9 plus P of X equals 10. Equals 10 C7 1 by 2 power 7 1 by 2 power 10 minus 7 plus 10 C8 1 by 2 power 8 1 by 2 power 10 minus 8 plus 10 C9 1 by 2 power 9 1 by 2 power 10 minus 9. And plus 10 C10 1 by 2 power 10 1 by 2 power 10 minus 10 equals 1 by 2 power 10 into 10 C7 plus 10 C8 plus 10 C9 plus 10 C10 equals 1 by 10 24 into 120 plus 45 plus 10 plus 1 is equal to 176 by 10 24. Problem 7. The mean and variance of binomial variate X are 16 and 8. Find I, P of X equals 0, 2, P of X equals 1, and 3, P of X greater than or equal to 2. Solution. Given NP equals 16 and NPQ equals 8. NPQ by NP equals 8 by 16 implies Q equals 1 by 2. Therefore P equals 1 minus Q equals 1 by 2. We know that P of X equals NCX P power X, Q power N minus X, I, P P of x equals 0 equals 32c 0 1 by 2 power 0 1 by 2 power 32 minus 0 is equal to 1 by 2 power 32. 2. P of x equals 1 equals 32c 1 1 by 2 power 1 1 by 2 power 32 minus 1 is equal to 32 1 by 2 power 32. 3. P of x greater than or equal to 2 is equal to 1 minus P of x less than 2. Equals 1 minus of P of x equals 0 plus P of x equals 1. Equals 1 minus of 1 by 2 power 32 plus 32 1 by 2 power 32. Equals 1 minus 33 into 1 by 2 power 32. Problem 8. Fit a binomial distribution for the following data. x0 f5 by 1 f18 by 2 f28 by 3 f12 by 4 f7 by 5 f6 by 6 f4. Total 80. Solution. Let x follows binomial distribution with parameters b of n, p, capital N equals total frequency equals 80 and small n equals number of trials equals 6. First we have to find mean. In the first column x value, second column f value, and third column fx. X value 0, 1, 2, 3, 4, 5, 6. F value 5, 18, 28, 12, 7, 6, 4. Fx value 0, 18, 56, 36, 28, 30, 24. Total 80, 192. Mean equals summation fx by summation f equals 192 by 80 is equal to 2.4. Therefore NP equals 2.4 implies that 6p equals 2.4 implies that p equals 0.4. Therefore Q equals 1, P equals 0.6. The theoretical frequency is given by n into P of x equals x. In first column x value, second column P of x equals x, third column 80 into P of x equals x, and the last column expected frequencies. In fourth column round off value instead of third column. X P of x equals nc x p power x q power nx 80 into P of x equals x. X equals 0 P of x equals 0 equals 6c 0 into 0.4 power 0 0.6 into power 4 to 0 equals 0.046780 into 0.0467 is equal to 3.734. X equals 1 P of x equals 1 equals 6c1 into 0.4 power 1 0.6 into power 4 to 1 equals 0.186680 into 0.1866 is equal to 14.9315. X equals 2 P of x equals 2 equals 6c2 into 0.4 power 2 0.6 into power 4 to 2 equals 0.311080 into 0.3110 is equal to 24.8825. X equals 3 P of x equals 3 equals 6c3 into 0.4 power 3 0.6 into power 4 to 3 equals 0.276580 into 0.2765 is equal to 22.1222. X equals 4 P of x equals 4 equals 6c4 into 0.4 power 4 0.6 into power 4 to 4 equals 0.136980 into 0.1369 is equal to 11.0611. X equals 5 P of x equals 5 equals 6c5 into 0.4 power 5 0.6 into power 4 to 5 equals 0.0.03698 into 0.0369 is equal to 2.953. X equals 6p of x equals 6 c6 into 0.4 power 6 0.6 into power 4 to 6 equals 0.004180 into 0.0041 is equal to 0.3270.